Hello everyone, welcome to Eduxcite classes. My name is Monit and today we will discuss A.3.1 work, energy and power. This is the part 2. Basically the questions for work, energy, power are intermixed. So what I have done is I have made the work, energy, power as complete one questions worksheet, and it has been discussed in two parts, part 1 and part 2. Okay, so just have a check. You can find out the PDF as well as the marking scheme. Whatever I will do in this particular video, you can find out the PDF on this particular link, and the link is also given in the description. If you have not watched my previous videos from A.1 and A.2, please go and check the playlist. The link is given in the description. And if you have any doubt and you want one-to-one sessions with me, you can scan the QR code for my WhatsApp, and we can have a discussion over the same. So these are certain important formulas that are given in your data booklet. I hope everybody knows, and you should carry a data booklet while solving the questions in this particular video. Some important points: that work done is equals to the area under the force distance graph. If a force distance graph is given to us, then the area of that will be equivalent to your work done. The energy density, there is only a small portion in this new syllabus about the energy density and the specific energy, so you should know the definition which I have mentioned here, and even the units are quite important. They may ask you a simple definition or the unit based question in your MCQ paper. So energy density is nothing but the energy transfer from per unit volume of any source of energy or fuel. So this will be energy per unit volume, joule per meter cube. Specific energy is the amount of energy that can be transferred from unit mass of an energy source per unit mass. So joule per kg is the SI unit. Okay. So I will give you the time to pause the video, and you can solve the questions with me, and then you can check your answers. Okay. So let us start with the very first question. Pause the video and solve. Okay, so solution 1. Now if you look at the graph is a force versus displacement is given to us. So this is from 0 to 10. They are asking us the ratio of the velocity at 6 second and at the 10th second. So how we can do is, we know that the object is moving on horizontal road and we are assuming no friction. So the work done will be equals to the kinetic energy. So the area of this part will be equals to, let us say, for V6 we are doing, right? So area under graph is nothing but the work done, and that work done will be converted into kinetic energy. So I will equate like this. How? So 45 times 6 will be equals to half m into V6 square. V6 stands for the velocity of the object at 6 seconds. So using this, can I write down V6 will be nothing but 45 into 6 times 2 will be 540. I have already done the calculation. Yeah, so this will be 540 by m. So this will be my equation 1. Similarly, for V10, what we can do is, for V10 we can find out the complete. Do not find out this, because the speed is from 0 to 10 we have to find out. So the complete work done will be converted into the kinetic energy, and that kinetic energy will be, we will consider for V10. So similarly I can say the area, that is 45 into 6 plus half into base is 4 into 45 will be equals to half m V10 square. So when you solve for V10 square, you will get something around 720 by m. I have already done the calculation. You can use your calculator. So now the question is just V6 over V10. So if you do this, this will be under root of 540 by m times under root of 720 by m. So this will come out to be 0.87 will be the ratio. So that will be your answer for question number 1. So I hope it is quite clear how to solve for this. Now again pause the video for question number 2 and solve. Okay, so in this particular question, if you read it, this car is applying a constant brake in order to stop, and the car in that particular case loses an energy of 121 kilojoule and it comes to rest. We have to find out the mass of the car. Now in such type of problem, you have to make sure that if the kinetic energy is given, the braking force is given, the time is given, then think in terms of the momentum, force, time. That is the impulse, right? The change in, so change in momentum can be written as momentum final minus momentum initial. Momentum final is 0. I am taking the magnitude of this case, so I can write momentum initial as P. That will be the momentum initial of the car, right? And we know that kinetic energy is related to momentum as P square upon 2m, right? So using this relation, which we have already discussed in my previous video, if you have not watched, you can go and have a look over it. The link is given, the playlist link is given in the description. Now if I want to find out m, I can write m as P square over kinetic energy times 2, right? So my mass will be P square momentum, and P, yeah, again P momentum is change in momentum can be written as force times time. If you remember from the impulse particular video, it is given in your data booklet. So I can write force times time square divided by kinetic energy into 2. Now put up the values. So force is how much? 2280. Time is 7.96. This is square over kinetic energy is 121 into 10 raised to power 3 into 2. So if you put up this in your calculator, you will get mass something around 1361. Rounding off into 3 significant figure, it will be, as per the question, 1360 kg. Okay, I hope it is quite easy. If you have any doubt, just comment below, guys. I will try my level best to clear all your doubts. Now pause the video and solve question number 3. Okay, so this becomes a very good question, guys. The reason being, it includes your concept of circular motion plus your energy, work and energy, right? So now what is happening, let us say this is a height of 100 meter from the ground, and the roller coaster goes like this, and the question is, what is the maximum radius that the loop can have if the cart is to clear the top of the loop without slipping? So just it turns without slipping. So in that case, can I say at this particular point, the weight is acting in the downward direction mg, and normal reaction we can consider as 0, because we have to find out the maximum radius without slipping. So it will just cross, so it will be almost equals to 0. So in that case, at the top, I can say at the top, the centripetal force, that is mv square by r, will be equals to mg, right? So the one equation is this that will be required, and using the work energy principle or energy conservation, you can say, by energy conservation, assuming no loss of energy, nothing is mentioned, so we will assume no friction and no loss of energy. So we can say at initially the energy is mgh is the 100 meter. So this will be converted into the energy at this point, which will be, now kinetic energy we will not consider, because it is just has to move, just has to complete the loop. So when it has to complete the loop, the velocity will be 0, and there will be certain gravitational potential energy. If this is the radius r, let us take it as small r, so this will be mg into 2r, because the height from the ground will be 2 times of radius, right? So if we use this now, from this particular equation I can write down a relation of, no, it will not be 0, sorry, we can find out the relation of the velocity at the maximum at the given radius, right, without slipping. My mistake guys, this not be 0, I was thinking something else. If it will be 0 then it will fall down, sorry, it will have some minimum velocity. Okay, so using this we can find out the relation for v, or v square can be written as m, and m gets cancelled, it will be g times r, right? So and in this equation if you look, the m, this m and this m gets cancelled, so we got g h equals to v square I am placing as g r by 2 plus 2 times of g into r. So from here you can say the g will get cancelled out, so the remaining equation is h is equals to r by 2 plus 2r. So h we already know, so this will be 5r by 2. Now h is 100, this will be 5r by 2, so this will be 20 times 2, this will be 40 meter. So 40 meter will be the answer for this particular question. Okay, so yeah, this was quite good question. Now pause the video, train your mind to solve question number 4. Okay, so in this particular question, if we have read it carefully, what is happening is this wooden block is being compressed and it is free to move, and it is moving up the inclined plane and it reaches a maximum distance d. Now in this particular question we have to find out what's the maximum distance the block has covered before coming back down the slope. Okay, so using the, we can say using principle of conservation of energy. So the initial energy is the energy in the spring, elastic potential energy of the spring, which is half times k x square. Now this energy is moving and I am taking the energy, total energy at this particular point. So this, in this particular point, it is just about to move back, so there will be no velocity at the maximum distance, the velocity will be 0, so there will be no kinetic energy. So you can say half mv square, this will be 0 plus, now it will gain certain height. If you look at this particular, so the height will be this much, so this will be the vertical height delta h. Now if this is d, this is 35, we can say this will be d sine 35. So there will be a potential energy, gravitational potential energy of mg into d sine of 35, right? Plus due to friction there will be a work done against the friction, so some energy will be lost in the friction, and the work done by the friction is the friction force times displacement is d. Okay, so now if we got this, we can find out d. Now friction, we know friction is what? Friction is nu times n, and in an inclined plane, if you remember, if this is mg, this will be mg cos 35, okay, and this will be n, right? So it is inclined, so it will be perpendicular, so this will be nu times mg cos of 35. So if I place up all the values, half k x square is equals to mg d sine 35 plus nu mg cos 35 times, this is friction times d. Now if I take mgd common, or we can find mg d common, and this is sine 35 plus nu cos 35 equals to half k x square, right? Now we have to find out d, so d can be written as kx square over 2 times of mg times sine of 35 plus nu cos of 35. Why I am doing like this? Because if you put the values in beginning, you may have got some errors. So in order to minimize your errors, you should put up the values in your last equation. Okay guys, so now we know the k, we know x, we know m, we know g. You can put up the values. So if I want to put up the values, this will be 55. Now if you look at the displacement, compression of the spring, it is 5 centimeters. So in meter it will be 0.05 square divided by 2 times of mass of 60 grams, so 60 into 10 raised to power minus 3 into 9.8 times sine 35 plus nu is 0.61 cos 35. Now if you solve this in your calculator, you will get something around 0.1089 meter, or in 2SF 0.11 meter. So this will be your answer for question number 4. I hope it is quite understood. If you have any doubt, just let me know. Okay, now pause the video for question number 5 and solve. Okay, now this is a quite good question. So the efficiency is given to us as 31.2 and the length of the blades are 28.5 meter. Air density is given to us and the power output of the wind is given to us. We have to find out what will be the horizontal velocity of the wind. Now in this case, first of all, let us find out the power input. Now we know the efficiency formula, it is given in your data booklet. So power input will be power output, which is 586 into 10 raised to power 3 divided by efficiency 31.2 divided by 100. Now if you solve this, you will get 1878.2 kilowatt. I have already done the calculation. You can check in your calculator. Now this power input resembles what? This power input signify that is the kinetic energy of the wind passing through the blades of the turbine in 1 second. Can I say like this? Because power is energy per unit time. Now if I time taken as 1 second, then I can say the magnitude wise the power input will be equals to the kinetic energy. Now if I equate the same 1878.2 into 10 raised to power 3 as half mv square. Let us say v is the speed of horizontal velocity of the wind. Now mass, amount of mass passing through the wind of the turbines, blades of the turbines in 1 second, I can say half density time volume. This is volume and this is velocity, and density is given to us. Volume in 1 second, if you look at diagram, in 1 second this much amount of air will be blown. So can I consider this as a cylinder? So I can say pi r square h, and in h will be equals to v in numerical, because velocity will be in 1 second. This will be the length of the cylinder or the length of the air column. So I can say this will be pi r square h times v square. Now I am writing h is equals to v in 1 second. So I can rewrite 1 pi r square into v cube. So the final equation is this, and this is equals to 1878.2 into 10 raised to power 3. So v will be equals to 2 into 1878.2 into 10 raised to power 3 divided by density is given to us 1.24 pi radius is given 28.5 square, so this will be raised to power 1 by 3. So if you put up the value, you will get V something around, rounding off into 3 significant figure, will be 10.6 meter per second. I have already done the calculation, guys, you can check. So this will be your answer for question number 5. So I hope I tried my level best to solve some important questions of the work, energy, power principle. Now my only request is to please share this video as much as you can and keep learning with me. In the next part of this video, we will solve some few more important questions related to work, energy and the MCQ questions. See you in the next video. Take care. Bye-bye.